All right, welcome back. I like to do these little videos in small increments because I was able to go and make dinner. I made some linguine and clam sauce, and it was the bomb diggity snip snap snack sack. It was awesome. So I'm in a better mood. Come back more energized with the linguine, ready to go with this stuff. All right, back to 2.5. One of the challenges with this section is that is that there is a lot of algebra, and so you have to be really, really careful on how you organize these problems. So let's do an example where I want to find the derivative dy dx of the implicit equation y squared plus 3y minus 7x to the fifth plus 2x is equal to 8. And I want to find dy dx. Okay. Occasionally, for some reason, this program stops, so like occasionally it just happened like about 30 seconds ago. So I have to go back and pick up where I was. It kicks me out. So hopefully this will go a little more smoothly. All right, maybe I got excited about the linguine and then I hit the wrong button. Okay, anyway, here we go. So I want to find dy dx. So step one is we're going to take dy dx of both sides. Okay, so I've got this implicit equation. Let's go back and look up the equation. See, with this equation, you can't solve for y as a function of x because you got that y squared, you got that y, and so this is an implicit equation. So instead of worrying about solving for anything, I'm just going to leave it alone, and I'm just going to take d dx of both sides. And I'm going to distribute the derivative if I have sums and differences, never products and quotients. So I'm going to take d dx of the first term, which is y squared, plus 3y. I'm going to pull the 3. Remember, you can pull constants out of the derivative. So d dx of y minus 7 I'll pull out, d dx of x to the fifth, plus 2 I'll pull out, d dx of x, and that's equal to d dx of 8. Okay. So let's go through this step by step. Okay, so the first one, if I'm taking the derivative of y squared with respect to x, it's just like with the chain rule when you're doing u squared. So the derivative of y squared is going to be 2y, so 2y to the first, times the chain, and the chain is dy dx. So that's that y prime. Plus, I've got 3 times the derivative of just y. And then we're going to use the chain rule again, so because x and y are different. So the derivative of just y is 1, but I've got to multiply it by the chain, which is dy dx. Minus 7 times the derivative of x to the fifth, and the derivative of x to the fifth with respect to x is 5x to the fourth. That's same. So the chain is 1, dx, so I'm not going to write it. Plus 2 times the derivative with respect of x with respect to x, which is just 1. And that's equal to the derivative of 8, derivative of constants is 0. Okay, so I went through and I found the derivative of each piece. Now, for step 2, and this is an important step, and this is where you have to really be careful with how you write this, is you want to get anything touching, so anything with dy dx on the left-hand side, and everything else on the right-hand side. And this one's a little on the easier side, so I don't have to multiply out to isolate my dy dx. So what I'm going to do is anything that's not touching a dy dx, which is these terms here, I'm going to bring these over to the right-hand side. So I've got 2y times dy dx plus 3 times dy dx, I'm keeping those on the left-hand side because they're dy dx terms, is equal to, if I bring those other terms over, I'm going to get, well actually, oops, let's do this. 7 times 5 is, great, I erased more things here. All right, let's do that. And okay, so up here, so it's negative, so it's going to be positive when I bring it over, but 7 times 5 is 35. So that's 35, x to the fourth minus 2. Okay, so now what I'm going to do is the next step is I'm going to solve for dy dx. So step 3 is I'm going to solve for dy dx. Okay, so what I'm going to do is both of these terms have a dy dx. So I'm going to factor out the dy dx, and I have dy dx times 2y plus 3 is equal to the right-hand side, which didn't change, which is 35x to the fourth minus 2. The last step in this puzzle is I just divide both sides, because I'm solving for dy dx. So again, you're solving for dy dx. So I'm going to divide both sides by this term 2y plus 3. So dy dx then is equal to 35x to the fourth minus 2 all over 2y plus 3. And this describes the derivative at any point on this implicit equation. Okay, let's do a practical example with this. So I'm going to actually, wrong grid, I'm going to actually use the same derivative. So here we just found that dy dx for that particular function was equal to 35 x to the fourth minus 2 all over 2y plus 3 and plus 3. And so what I want to do is, for an example, is I want to find the equation for the tangent line of the tangent line on the graph of this equation at the point xy is equal to 1 comma 2. Okay, so I don't know what this graph looks like, but I do know that at point x is 1 and y is 2, I want to find the equation for the tangent line. This is the exact same thing we did before with explicit functions, or explicit equations, which are functions. So I'm going to use the equation y is equal to mx plus b. Okay, so I don't know what this graph looks like, but let's just say for sake of argument it looks something, I don't know, like this. Okay, so at this point of interest, what I'm going to do is, I know that my slope here is dy dx, the slope of the tangent line. So this slope m is going to be this, this whole equation y equals mx plus b is the equation for this line. And the slope m at the given point 1, 2 is going to be equal to dy dx at point 1, 2. Okay, so the first thing I'm going to do is, I want to find the equation for this line, is I'm going to use dy dx, which I found before. And so if I go up here, then dy dx at point 1, 2 is, all you do is you put in the values of x and y. So I've got 35 times x value is 1 to the fourth minus 2. All over 2 times y, which is 2 plus 3. And so my slope here is going to be 33 over 7. And that's my m, the slope of this tangent line. So what I want to do now is I want to find the equation for this tangent line, the blue dashed line. So that's y is equal to mx plus b. And now it just becomes an algebra 1 problem. I know what my slope is, I have the given point, so I need to find my intercept b. So my y value is 2, my slope of this line is 33 over 7, my x value is 1, so my value of b is going to be 2 minus 33 over 7, or I'm going to write 2 as 14 over 7 minus 33 over 7, so b is going to be equal to negative 19 over 7. So now I'm going to rewrite my equation for my tangent line. So y is equal to my slope of that tangent line, which is 33 over 7, times x, and then plus my y-intercept, which is minus 19 over 7. So this is actually, this tangent line is drawn a little bit incorrectly up here because the y-intercept is actually a negative number. So maybe it's something that looks like that. And then sometimes on the AP exam, they'll give you the equation, like let's say this is a multiple choice question. They may give it to you in standard form instead of the, for the line, instead of y equals mx plus b, which is the slope-intercept form. So to get this in the standard form, remember you multiply, just multiply by 7 and then put it into standard form. So this equation for a line in standard form is 33x minus 7y is equal to 19. Just as long as you can recognize that, and that's it. That's how you do it. So when we come back, I'm gonna go make some tea this time. I'm feeling chai. Oh man, okay, we're doing to get some chai going, and I'm gonna come back and we're gonna do some more complicated examples.